Welcome back, everyone, from winter break. Today we're going to be starting Unit 5, and this first lesson looks at the Pythagorean Theorem and its converse, and also allows us to revisit special right triangles that you were introduced to during the Cornerstone activity last semester. So let's first look at the Pythagorean Theorem. If in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. What we're saying is if we square both of the legs and add them together, that will equal the square of the hypotenuse. The converse of that is also true. If you don't know that it's a right triangle, but you're given the lengths of the three sides, if the two shorter sides squared are added together, then they should equal and they equal the square of the hypotenuse, then you know that it is a right triangle. Sometimes we like to recognize when we've seen Pythagorean triples. Pythagorean triples are three numbers that satisfy the Pythagorean theorem, and if you recognize them, then you don't have to use the Pythagorean theorem every time. The first most common one is the 3, 4, 5, and don't forget you can use the multiple of 3, 4, 5. So if you see a triangle with legs that are 6 and 8, then you know the hypotenuse is 10 because that's a 3, 4, 5 triple multiplied by 2. Another common one you see is the 5, 12, 13. 8, 15, 17, and 7, 24, 25 come up every so often, not as much as the others. And there are actually many, many more Pythagorean triples, but these are the ones that you should keep your eye out for because they'll save you some time. So we can now, for the first time, I think you're going to see, we can use the Pythagorean theorem to help us identify if a triangle is acute or obtuse, meaning that it's not right. So the c squared does not equal a squared plus b squared, but instead it can be greater than or less than. So this first theorem says, if the square of the lengths of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is an acute triangle. So notice here that c squared is less than a squared plus b squared, then the triangle is acute. If, in the second theorem, c squared is greater than a squared plus b squared, then the triangle is obtuse. And then don't forget, if c squared is equal to a squared plus b squared, then we know the triangle is right. So let's look at a couple of examples. This first one here is just asking us to find x. Now, if you notice right away that we've got a leg that's 6 and the hypotenuse that's 10, that is a 3, 4, 5 Pythagorean triple multiplied by 2. So if you use your Pythagorean triples, you should recognize that the other leg is 8. But if you don't recognize that, you can use the Pythagorean theorem. X squared plus 6 squared equals 10 squared. So x squared equals 64, square root both sides, and x is 8. Okay? For the next one, we've got a leg that's 11 and a leg that's 12. That's not a Pythagorean triple, so we're going to go ahead and use the Pythagorean theorem. And we get 121 plus 144 equals x squared. That's 265 equals x squared. If you square root both sides, x is just the square root of 265. All right. Now, in these next couple of problems, we're looking to see if the triangle is right, obtuse, or acute. But don't forget, you always have to first check to make sure that those side lengths actually make a triangle. So if you remember back from Unit 1, we said that any two sides of a triangle have to add up to be greater than the length of the third side. So let's just make sure we check that before we even see what kind of triangle it is. So in this first one here, 9 plus 40 is 49, which is greater than 41, so we know that this is a triangle. So I'm going to set up the Pythagorean theorem to see if this is right, obtuse, or acute. So I set up 41 squared. We don't know what the relationship's going to be with 9 squared and 40 squared. So I get 1681, something to 81 plus 1600, and so we get 1681 is equal to 1681. So a squared plus b squared equals c squared, so this must be a right triangle. Looking at the next one, 6 plus 7 is 13, which is greater than 8, so we know it's a triangle. So I'll set up Pythagorean theorem. So I get 64, 36 plus 49, and I get 64 and 85. Now 64 is less than 85, and if c squared is less than a squared plus b squared, then we know that the triangle is acute. Looking at C, we've got 7, 8, and 11. 7 plus 8 is 15, which is greater than 11, so we know it makes a triangle. 11 squared, 7 squared plus 8 squared, so I get 121 to 49 plus 64. So that's 121, which is going to be greater than 113. Well, if c squared is greater than a squared plus b squared, then it must be obtuse. Okay. And the last one, D, we've got 3, 4, and 8. 3 plus 4 is 7, which is less than 8. So this is not even a triangle. So we don't even have to see if it's acute, obtuse, or right. Okay. Going on to special right triangles, this is kind of summarizing what we talked about in the Cornerstone project. When you look at a isosceles right triangle, which is a 45-45 right, remember that the legs are going to be the same length. So if I call both legs x, then the hypotenuse will be radical 2 times the length of the leg. So that's going to be our x radical 2. And if we look at a 30, 60, 90, if the side opposite the 30 we call x, then we know that the hypotenuse is going to be 2 times that side, so the hypotenuse is 2x, and the longer leg is going to be radical 3 times that side, so x radical 3. So using these rules, let's see if we can find the missing sides of the following triangles. So looking at example 3a, I notice that this is an isosceles right triangle. So this leg also has to be 72, and then the hypotenuse would have to be 72 radical 2. In the second example, they give us the hypotenuse is 13 radical 2, which just tells us then that the legs are going to be 13. This last one's a little tricky because in the last one they tell us the hypotenuse is 10. But 10 has to be our x radical 2 side. So if I set 10 equal to x radical 2, and we divide by radical 2, and then to rationalize, I multiply by radical 2, and I get 10 radical 2 over 2, which is 5 radical 2, then that is equal to x, which is the length of each of the legs. Now, if you understand all that algebra, you can just remember a shortcut. Whatever the hypotenuse is, just divide it by 2 and multiply by radical 2. The hypotenuse is 10. 10 divided by 2 is 5. 5 times radical 2 are your legs. Now let's look at the 30, 60, 90. In this 30, 60, 90 in A, we've got the side opposite the 30 is 5. So that means our hypotenuse is going to be 2 times 5, which is 10. And the side opposite the 60 will be 5 times radical 3. All right. For B, this time they give us the hypotenuse. Now that's our 2x side. So if 2x is 20, then x must be 10. So the side opposite the 30 is 10, making the side opposite the 60 10 radical 3. Now this last one is similar to the last one above. We've got the x radical 3 side equaling a whole number. So we're going to have to figure out a way to get the x. So I'm going to say 17 equals x radical 3. If I divide by radical 3 and then multiply by radical 3 over 3 to rationalize, I get 17 radical 3 over 3 is equal to x. That's as far as you can simplify it, but that is your x value, so that's the side opposite the 30. And then we still have to double that for the hypotenuse, so 17 times 2 is 34 radical 3 over 3. Now similarly, there's a shortcut here. If you get the side opposite the 60, the radical 3 side, you can divide by 3 and multiply by radical 3 for the shortcut. Then you don't have to do all of the algebra here. All right, let's keep going. The congruent sides of an isosceles triangle measure 6 and the base measures 8. Find the length of the altitude. All right, well, let's first draw a diagram. We've got an isosceles triangle with legs that are 6, and the hypotenuse is 8. And they want us to find the length of the altitude. Okay, now we don't know the measure of any of these angles except the right angle. And if I use the altitude as a reflexive side, I can say that these two triangles are congruent by hypotenuse leg, which then allows me to say that these two sides are congruent, so they are each 4. All right, and now I'm just going to use the Pythagorean theorem to find the length of the altitude, and that's a leg. So I have x squared plus 4 squared equals 6 squared. And so I get x squared equals 20, square root both sides, and x is radical 20, which can be simplified to 2 radical 5. All right, let's go on to our last example here, example 6. Specify all the values of x and make the statement true. All right, so the first one says the triangle is isosceles. Well, in order for a triangle to be isosceles, it has to have 2 sides congruent. But we always have to check to make sure that it still makes a triangle. So let's say, could x be 6? Well, 6 plus 6 is 12, which is greater than 8. So yes, x can be 6. But what if x is 8? 6 plus 8 is 14, which is greater than 8. So it could also be 8. Now, part B, no triangle is possible. Well, if no triangle is possible, then we've got to figure out what wouldn't work here. So let's say 8 is the longest side. If 8 is the longest side, then I'd say 6 plus x would have to be greater than 8, which means that x would have to be greater than or equal to 2, because if it's 2, it still won't be a triangle, but if it's 3, then we know we have a triangle, or even 2.1. On the flip side, though, let's say that x itself is the longest side now, and that means that 6 and 8 have to add up to be greater than x. Well, then that means that x has to be less than or equal to 14, because if x is 14, it wouldn't make a triangle, and if x is less than 14, it wouldn't make a triangle. So I can put these two together and say 2 is less than or equal to x, which is less than or equal to 14. For part C, y is a right angle. Well, if y is a right angle, here we go, then this is a right triangle. And if this is a right triangle, x is the hypotenuse. And so I notice my legs are 6 and 8. Again, this is a Pythagorean triple, a 3, 4, 5 multiplied by 2. So I know x is 10. But if you don't recognize the Pythagorean triple, you can use the Pythagorean theorem. So you get 36 plus 64 equals x squared. 100 equals x squared. So x is 10. What if angle y was obtuse? Well, if angle y is obtuse, then it's an obtuse triangle. And an obtuse triangle, we know that c squared has to be greater than a squared plus b squared. Well, we know that c, in this case, was 10. So then we're just going to say that x would have to be greater than 10 in order to make this an obtuse triangle. But we also have to be careful, is it can't be anything greater than 10, right? It has to end at some point, and that's where 14 comes in, because if x is 14, then it won't be a triangle at all. Last one is if x is an acute angle. Well, if x is an acute triangle, if y is an acute angle and the triangle is an acute triangle, then we would have to say that x is less than 10, because we know that c squared has to be less than a squared plus b squared. But can it be anything less than 10? Well, no, because it has to be cut off at 2, because if it's less than 2, or if it's even equal to 2, then we don't have a triangle at all.